arctangent of negative square root of 3. Where are we thinking? Do I like 11 pi over 6? Why not, Nina? So let's think back. Let's do a little sidebar action here to start. So tangent and what? What two inverses are on the right side? Sine. So tangent and sine inverses have to be from negative pi over 2 to pi over 2. Right? So 11 pi over 6 doesn't fall in that range, but what does? Or negative pi over 3, because it was 5 pi over 3. It should be 5 pi over 3, right? Okay? So negative pi over 3 does. We're talking literally about the same angle, but this one falls in my acceptable answer range. Okay. Cosine, continue on our sidebar, inverse cosine has to be what? Where do I find the inverse cosine ones? Top half, right? So that's from 0 to pi. Okay. Tangent and sine inverses are on the right half, cosine on the top half.
What if for number 1 you just put pi over 3 instead of negative pi over 3?
You would be wrong.
Because it's still in the right.
No, it's not. Pi over 3 is in the first quadrant.
Yes.
Negative pi over 3 is in the fourth quadrant. They are not the same.
Oh, okay.
Okay?
Yeah.
With me?
Yeah.
Yep. Right? Inverse cosine of negative 1. Pi? I like pi. Favorite kind? Favorite kind? What? Apple? Warm? Single scoop of vanilla ice cream on top? Nothing better. Okay. Arc sine of negative 1/2. Arc sine negative 1/2. Negative what? Negative pi over 6. Because on the unit circle, we find it at 11 pi over 6, right? But that's not in my range, my acceptable range, so that's why we write it as negative pi over 6. Why is this one number? Because the cosine at pi, so I'm looking for on the top half of the unit circle, where is the cosine negative 1? That happens at pi. On the top half. That's still technically in that acceptable range. Okay? So, we decided in my first class that it was Emeril Lagasse from the Food Network that says, let's kick it up a notch, and he throws some more flavor in his food, and he makes this wonderful tasting stuff that I have no idea what's going in it, but supposedly it tastes good because I can't taste through my TV yet. Okay? So let's kick it up a notch. Okay? Let's go to compositions of trigonometric functions and their inverses. Okay? So we need to evaluate using the unit circle, exact answers, angle answers in radians. Okay? Now, when you're dealing with a composition of functions, okay, like we are here, sine of arc cosine of 1/2, that's a composition of functions. I've got two functions going on. I take the inside function first, and I evaluate that first. So, where is arc, or what is the value of arc cosine of 1/2? Sam? It's pi over 3. Okay? So this is pi over 3. So really, what I'm looking for here now is I am looking for the sine of pi over 3. What do you got? Square root 3 over 2. Okay? So the sine of the arc cosine of 1/2 is equal to the square root of 3 over 2. Okay? Let's try another one. Cosine of the inverse sine of negative square root 3 over 2. Well, deal with this part first. Sine, the inverse sine of negative square root 3 over 2 is what? No, not in my range. Negative pi over 3. So this is the cosine of negative pi over 3. And what is the cosine at negative pi over 3? 1/2. Okay? You try those two. Arc cosine of root 3 over 2. Pi over 6. Cosine at pi over 6. Cosine of pi over 6. Square root 3 over 2. Okay. All right. What's up?
I have a question. Can't you just like cancel out the arc cosine and the cosine because they're like inverses of each
I was
other?
going to ask that question after this next one.
Sorry.
No, that's great. I love it. Why can I do that?
Because they're inverses.
Because they're inverses of each other, right?
Yeah.
Adding 4 and subtracting 4 cancels each other out.
Yeah.
Multiplying by 4 and dividing by 4 cancels each other out. Fourth rooting and fourth powering cancel each other out. Cosine cancels out arc sine or inverse, cosine cancels out arc cosine or inverse cosine. They cancel each other out. So technically, what you're saying here is that when you have the cosine of the arc cosine of the square root 3 over 2, you're saying that these two cancel each other out, and you're just left with square root of 3 over 2. Okay? Logic, right? So down here, what should this one be? Square root 2 over 2. Right? Okay. Whoa. Cancel. I have no idea why that popped in there. Okay? So this should be that. Okay? Let's check it using the long method that we've been doing. Okay? So that gets me pi over 4. Right? So then this would be the sine of pi over 4, which is square root 2 over 2. So it works. Okay? Right? Try it on those. So according to our logic here, this should cancel out that, and I should get pi over 3 in the end. Okay? Let's check it. sine of pi over 3 is square root 3 over 2. So this is the inverse sine of the square root 3 over 2, which is pi over 3, right? Yeah? Love it. Okay? So according to this, or according to that logic, then this should cancel out that, and I should get 5 pi over 3 in the end, right? Uh-oh, I see some people shaking their heads. What's wrong with that logic in this one? What do you got, Dylan?
Because the range of sine would be from negative pi over 2 up to pi over 2. You have to change the pi over 3 to negative pi over 3.
Boom goes the dynamite. If you had a mic right now, you could drop it. Okay? All right? So the problem is we still have to be in those acceptable ranges of what we're dealing with. So yes, the sine at 5 pi over 3 is negative square root 3 over 2. We all agree with that. So that means then that I have to find the inverse sine of negative square root 3 over 2, which needs to then be in that negative pi over 2 to positive pi over 2 range on the right side of my unit circle. So that becomes then negative pi over 3. So yes, it still works, but I gotta adjust stuff. Okay? Yep, I'm gonna have to adjust things to get into it. Okay? Try those two. Is 2 pi over 3 in my acceptable cosine range? Yes. So the answer here is 2 pi over 3. If you wanted to, you'd find the cosine at 2 pi over 3. That'd be negative 1/2. Then you'd have to find the inverse cosine of negative 1/2, which puts you right back at 2 pi over 3. Okay? Is 5 pi over 3 in my acceptable cosine range? No, that's not. So I can't just quick use that shortcut on this one. So I'm looking here at what's the cosine at 5 pi over 3? 1/2. So this then becomes the arc cosine of 1/2, which is pi over 3. Okay? So we have to do some adjusting, even in cosines. Okay? Flavorful, wonderful type of stuff. Okay? Now, let's take it to even a higher level. Okay? Let's jump off the unit circle and just go to any old triangle. Okay? So, how I would go about these, and we want exact answers, so that means fractional answers or radical answers, okay? Not rounded, none of that rounded stuff, okay? So what I would do is I would first evaluate the inside. Where is, which quadrant, I should say, where, in which quadrant, is arc cosine positive? Quadrant number 1, right? So I am going to draw myself a triangle in quadrant number 1. So much so that I'm even going to put the origin right on there. Okay? Then this here is my theta. Right? Because this arc cosine, that's going to give me an angle. Inverse trig functions give me angles. Regular trig functions give me values. That hasn't changed. Okay? Inverse gives me angles. Okay, so that's going to be an angle. So really here, I am looking for the sine of theta. Okay? Now, what do I know about the triangle containing theta? Cosine is what in my SOHCAHTOA-ness? Adjacent over hypotenuse. So my adjacent side down here is 4, and my hypotenuse is 5. Knowing what you know about Pythagorean triples, what's my missing side? 3. Okay? 3, 4, 5 makes a Pythagorean triple. Okay? What if we didn't know that that was 3? You'd use the Pythagorean theorem. Blank squared, or whatever squared, plus 4 squared equals 5 squared. So 25 equals 16 plus whatever squared. 9 equals whatever squared. 3 has got to be what it is. Okay? So I am looking for the sine of that angle. Sine in my SOHCAHTOA is opposite over hypotenuse. What's the opposite side? 3. What's the hypotenuse?
5.
This one's 3/5. Let that soak in a little bit. Okay. Got it? You now, or let's go through this one again together. Where is inverse sine positive? Which quadrant? Quadrant number 1. So this, I'm really looking for here the cosine of theta. Oops, I should have stayed up. OCD's kicking in. It happens. It's a real thing. Okay, so I'm really looking for the cosine of theta. What do I know about theta's triangle? This side over here is, this side up here is, missing side down here is 12. Again, 5, 12, 13 is a Pythagorean triple. Okay, so what is the cosine of theta? 12 over 13. Okay? Now, we'll go even, we're loving this stuff. Okay? You try those two. Arc cosine being negative is in which quadrant? It's in quadrant number 2. So I'm going to draw my triangle in quadrant number 2. If I draw my triangle in quadrant number 2, theta is actually that one, right? Because theta starts out here at 0 and goes that way. So this really is theta prime, reference angle. getting us back into that swing. Okay, so cosine is adjacent, right? So this side over here is going to be my -8. That side up there is going to be my 17. Now I'm going to write it like that, and you'll see why here in a minute. Okay, what's my missing side? 15. Again, a Pythagorean triple. Okay, so this really is, I'm looking for the tangent of theta. Okay, so the tangent is opposite over adjacent. What's my opposite side? 15. What's my adjacent side? What's my adjacent side? -8. So this is -15 over 8. Because I'm in quadrant 2, tangent has to be negative. Okay? Secant of arcsine of -5/13. Arcsine being negative is where? Quadrant 4. So I'm going to draw my triangle like that in quadrant 4. This is technically my theta. Okay? So, or, because we're arcsine really, what should be my theta? I'm going to jump backwards here. This one should be my theta really, right? Because it's arcsine. Right? Because I'm dealing with arcsine and we have negative values there. Okay? So this really is the secant here of theta. Either way you want to think about it, I'd be okay with it because you're going to get the same answers. Okay? So sine is opposite, so that's my negative side. Over hypotenuse, that's that one, which leaves me with this being 12 then again as that one, right? Okay? So, secant. What is secant again? 1 over cosine, right? So that's 1 over, what's the cosine now of theta? 12 over 13. So I need to figure that out, and that is going to be 13 over 12. Positive or negative? Positive, because cosine's positive, and secant then would be positive in quadrant number 4. Yeah, buddy? That's all she wrote for today.